95% of the ocean has never been seen by human eyes. What lives in that darkness, at those pressures, in that silence, we genuinely do not know. In 1997, something down there made a sound. It was the loudest unidentified sound ever recorded in the history of ocean monitoring. And 27 years later, no one has been able to say with certainty what made it. The National Oceanic and Atmospheric Administration operates a network of underwater microphones originally built to track Soviet submarines during the Cold War. These hydrophones are sensitive enough to detect sounds from thousands of miles away and have been recording the deep ocean continuously for decades. In the summer of 1997, during routine monitoring, analysts at NOAA picked up an audio signal that did not match anything in their reference library. It was not a whale song. It was not geological noise. It was not mechanical. It was something else. And the scale of it was immediately clear to everyone who looked at the data. The summer of 1997 was not supposed to produce anything unusual. NOAA's hydrophone network was doing what it always did, recording the ambient sounds of the deep Pacific Ocean, cataloging the routine noise of a planet that never goes fully quiet beneath the water. Whale calls, distant shipping, geological activity along fault lines, all of it familiar, all of it classifiable. The analysts running the data had seen thousands of hours of ocean audio. They knew what the ocean sounded like. What appeared on their instruments on the 19th of June, 1997, did not sound like the ocean. The signal rose in frequency over approximately 1 minute, a characteristic that analysts noted immediately because of how specific it was. It was not a flat burst of noise. It had shape. It had a profile. It behaved, in the language of acoustic analysis, like something that was producing the sound intentionally, building, sustaining, and releasing. Multiple hydrophone stations confirmed the signal simultaneously, which meant triangulation was possible. The source was located in the deep Pacific Ocean, near the southern tip of South America, in one of the most remote and least explored regions of water on the planet. The team named it the Bloop, a casual name for something casual sounding, an internal designation, the kind of name you give something before you understand what it is. But the name made it sound small. What the data showed was anything but. Because when they ran the numbers on what it would take to produce a sound that size, the answer was deeply uncomfortable. The blue whale is the loudest animal on Earth. It produces calls that reach approximately 188 decibels, powerful enough to be detected by other whales across hundreds of miles of open ocean. The blue whale is the benchmark. When marine biologists encounter an unidentified ocean sound, the blue whale is the first comparison point. The bloop was not in the same category. The sound was detected across a network of hydrophone stations spanning approximately 5,000 kilometers. 5,000 kilometers is roughly the distance from London to New York. A single sound, originating from a single point, registering clearly on instruments spread across that distance, means the source output was not comparable to anything in the biological record. It was not louder than a blue whale the way a shout is louder than a whisper. It was louder by a margin that eliminated every known living creature from the list of possible sources before the analysis was even complete. The frequency profile added another layer. Low-frequency sounds travel further through water than high-frequency sounds, which is why whale calls carry so far. The bloop's frequency range was consistent with a very large, very slow sound-producing mechanism. The kind of mechanism that, in biological terms, would require a body of a scale that has no precedent in the fossil record, let alone in current marine biology. And here is where the investigation took a turn that nobody expected, because the sound did not just break records for volume, it broke records for something else entirely. Every category of ocean sound has a signature. Biological sounds, produced by living creatures, have specific characteristics in their frequency profiles that distinguish them from geological and mechanical sources. The way a sound rises and falls, the harmonic structure within it, the duration and shape of the signal, these are fingerprints. Trained analysts can identify the category of a sound source from its profile alone, often without knowing the specific source. The bloop's profile was biological, not geological, not mechanical. The shape of the signal, the way it rose in frequency, the duration, the harmonic content, matched the category of sounds produced by living organisms more closely than it matched any known geological or mechanical source. This was noted in the original NOAA analysis and has not been seriously disputed in the years since. The disagreement is not about what category the sound resembles. The disagreement is about whether anything alive could produce a sound of that magnitude. The bloop was heard once. On the 19th of June, 1997, It appeared on the instruments, lasted for approximately 1 minute, and then stopped. It has not been recorded again. Not in the years of continuous monitoring that followed. Not once in 27 years of the same hydrophone network recording the same region of ocean. Whatever produced it made the sound once, and then did not make it again. The location sits near the coordinates of some of the deepest water on the planet. The southern Pacific contains trench systems that reach depths where pressure is so extreme that no conventional submersible has spent meaningful time exploring. The deepest regions of this area remain, in practical terms, as unknown to science as the surface of a distant moon. Every characteristic pointed in a direction, and that direction made scientists deeply uncomfortable. In 2005, 8 years after the detection, NOAA offered its most complete official assessment of the bloop's likely source. The conclusion was an icequake, the sound produced when a large Antarctic iceberg fractures or runs aground, releasing energy through the water in a specific acoustic signature. The icequake explanation has genuine scientific support. Large iceberg fracture events do produce low-frequency sounds that travel enormous distances through deep ocean water. The timing in 1997 was consistent with significant Antarctic ice activity. The geographic location, while remote, was within range of Antarctic iceberg movement patterns. For many scientists, the icequake explanation closed the case sufficiently. A large enough ice event under the right conditions could plausibly produce a sound of the bloop's detected scale. But the icequake theory has not satisfied everyone. The specific frequency profile of the bloop, the rising shape, the biological signature in the harmonic structure, does not match the recorded profiles of confirmed icequake events. Icequakes produce sounds with a different shape. The bloop's profile remains closer to biological sources than to any confirmed icequake recording, and this gap in the explanation has never been formally resolved. The geological theory, submarine volcanic activity, or tectonic movement along a deep fault, faces the same problem. Geological sources produce flat broadband noise. The bloop had shape and direction in its frequency profile that geological sources do not typically produce. But there is one detail about the bloop that the icequake theory has never fully addressed. 95% of the ocean floor has never been directly observed. This is not a rhetorical statistic. It is an operational reality of marine science. The pressures at extreme depth make sustained exploration extraordinarily difficult and expensive. What has been observed in the fraction that has been explored has repeatedly demonstrated that the deep ocean contains life operating on principles and at scales that surface biology does not prepare you for. In the decades since 1997, deep ocean expeditions have discovered species of squid, fish, and invertebrates that were entirely unknown to science. Some of them large, some of them producing behaviors and biological outputs that had not been theorized before their discovery. The deep ocean has a consistent record of producing animals that should not exist by the standards of what was known before they were found. The coordinates where the bloop originated sit above trench systems that have received less direct scientific observation than the surface of Mars. What lives at those depths, at those pressures, in that permanent darkness? The honest scientific answer is that we do not fully know. We know what we have found. We do not know what we have not looked for, or what has not yet been in the path of anything capable of observing it. If the bloop was biological, whatever produced it has not made that sound again in 27 years of continuous monitoring, which means one of two things. Either it was a singular event from a source that no longer exists or no longer behaves the same way, or it is still down there, in water we have not seen, at depths we have not reached, and it simply has not made that sound again. The recording still exists. You can listen to it. The source still does not have a confirmed identity, and the ocean is large enough and deep enough and unexplored enough to keep that answer for as long as it chooses. The deep ocean has been there longer than anything walking on the surface of this planet. It does not give up its secrets easily. If this changed the way you think about what might be beneath the water, hit like, subscribe, and tell me in the comments. Do you think the bloop was geological? Or do you think something